Welcome to another deep dive. Today, we're pulling back the curtain on something that quietly underpins so much of our digital world. It often goes unnoticed, but it's open source.
It really is. It's, more than just code. It's a whole concept of philosophy that's completely changed how software gets built, shared.
And it impacts everything, right? From our phones to, well, the AI systems we hear so much about.
Exactly.
So our mission today is to sort of trace its journey. Where did these ideas come from? We'll look at some key figures, especially Richard Stallman, who was really pivotal.
Yeah, and we should also unpack the benefit. Like, what does open source actually do? Transparency, cost saving.
And how does it stack up against, the traditional way companies make software, the closed-off way?
Right. We'll compare it to proprietary.
Think of this as your essential guide. We want you to understand this invisible foundation of our world, even if you're not a programmer at all.
Okay, let's dive in.
Now, before we even get to computers and software, this idea of openly sharing technical know-how, it actually has a history, doesn't it?
Yeah.
Can you give us an example, like from before the digital age?
Oh, absolutely. What's really fascinating is that this isn't, a brand new idea born with computers. If you go back to the early 20th century, look at the American auto industry.
Okay.
Well, they had this big problem. There was a patent on a key engine component, a two-cycle gasoline, and it basically threatened to lock everything down, give one company a huge advantage. But instead of just fighting endless loss, Henry Ford challenged it.
Right.
And that led to something pretty radical for the time. Across license, all the U.S. automakers started sharing their patent open. No money changing hands, just sharing.
Wow, just sharing the knowledge.
Yeah. By World War II, hundreds of patents being shared. It really shows that this principle, sharing for collective benefit, it existed long before software. It can boost a whole industry.
That's a great analogy. Collaboration, really pushing things forward. So how did that same spirit translate to the early days of computing?
Well, back in the 50s and 60s, when you bought computer hardware, the operating software and compiler, those tools that translate code, they were usually just
part of the pack.
Exact, no separate. And crucially, the source code, the actual human readable instructions, typically too.
So you could see how it works?
Yeah, and you could fix bugs yourself or add new features if you needed them. Universities were big early adopters, and they naturally shared their modification. It fit with the whole academic culture of sharing knowledge.
Makes sense.
And group formed specifically for this, Share for IBM users, DQs for DC users. They were like the first coder communities, swapping software, often literally on magnetic tape.
On tape, right.
Some university lab even required that any program installed had to have its source code published. The A2 system from Univac factory is maybe the first example where they actually asked customers to send proof back.
So for a while there, sharing and collaborating just normal.
Absolutely, it was the norm. It fueled this early hacking curve, which back then meant creative problems, playful exploration, not break.
Right, a positive thing.
And then ARPANET came along in 1969, the internet's ancestor. That made exchanging code even easier, really cementing that collaborative way of.
Okay, so if sharing was the default, what happened? When did things shift toward companies locking up their code, making it proprietary?
Well, a couple of things happened. By the late 60s, software was getting more complex, and you started seeing a separate software industry emerge, competing with the hardware makers as bundles.
So commercial interests started playing a bigger role.
Exactly. But the really big shift was legal. Believe it or not, before 1974, software was generally considered copyrightable in the West.
Really?
Yeah. But then came the Cohen-Due decision in 74, and later court cases like Apple versus Franklin in 80. These basically gave software same copyright as books.
So that changed everything.
It paved the way for restrictive license. Suddenly, companies could legally stop you from copying, sharing, or modifying their code. This led straight to that shrink wrap model. You buy the software, but you only get the compiled version, the machine code, not the human readable.
Okay, so this sounds like it directly clashed with the values someone like Richard Stallman, who grew up in that earlier sharing culture. How did this affect him?
Deeply. Profound. You had things like Bill Gates' open letter to hobbyists in 76, basically saying, stop sharing our software without paying.
Right, I remember hearing about that.
Then AT&T started charging for Unix around 79. IBM stopped shipping source code in 3. For Stallman, who was working at MIT's AI lab, seeing this trend of only getting executable code, well, he found it ethically wrong.
Ethically wrong? Why?
Because it took away the user's control. Couldn't study how the program worked, couldn't fix it if it broken, you couldn't adapt it either. There's a famous story about him being frustrated by a printer at the lab that kept jamming, but he couldn't fix the software controlling it because the manufacturer wouldn't give them the source code. That kind of helplessness really drove him.
So faced with this shift, this loss of freedom, what did Stallman actually do?
He took action. In 1983, he launched the GNU project, and the name itself is a statement. It's a recursive acronym, GNU's not NEXUS.
Okay, what was the goal?
His goal was incredibly to build an entire computer operating system composed only of what he called free software.
And let's clarify free here. It's not primarily about price, is it? It's about liberty.
Exactly. That's the absolute key distinction Stallman always. It's free as in speech, not as in beer. He defined 4 essential freedom for software.
Okay, what are they?
Freedom 0, the freedom to run the program for any purpose. Freedom 1, the freedom to study how it works and change it so it does what you wish. Access to the source code is a precondition. Freedom 2, the freedom to redistribute copies so you can help others. And freedom 3, the freedom to distribute copies of your modified version to others. Again, source code access.
So it's all about user control and community.
Precise. And to give this structure, he founded the nonprofit Free Software Foundation, the FSF, in 1985. And he invented a really clever legal tool called copyleft.
Copyleft? What's that?
It uses copyright law, but flips it on its head. Instead of restricting sharing, copyleft requires that any modified versions or software built upon copylefted code must also be released under the same free terms.
So it forces the freedom to spread.
Exact. The most famous implementation modification is the GNU General Public License, or GPL. It's a legal guarantee that the software and anything derived from it stays free, preserving those four freedoms for all three. His goal was perpetuity.
Okay, so Stallman's building this free software alternative. But even with proprietary software taking hold, did that earlier, maybe less formal sharing culture completely die out?
No, not at all. The spirit was still alive. You know, hobbyists and hackers kept sharing code, find listings in computer magazines, programming books.
Right.
And on those early online bulletin board systems, the BBS networks like WWIV, modifying games or programs and sharing that source code was a really common thing.
A sort of underground sharing.
Kind of, yeah. And then things like Usenet and UQCnet came along in the early 80s. These connect programmers more direct, making it easier to share software and collaborate, even across long.
And then fast forward to the early 90s, something really big happened, this whole movement.
Yeah.
The Linux kernel here. Tell us about that.
Yeah, this was absolutely huge. 1991, Linus Torvald, just a 21-year-old student in Finland, announces he's working on a new operating system kernel.
The kernel being the core part of the OS.
Exactly, the bit that talked directly to the hardware.
Yeah.
He initially released it under his own, more restrictive license, but pretty quickly changed his mind and relicensed it under Stallman GNU.
Okay, why was that specific license change so important?
Because Stallman's GNU project had been working for years, building all the other parts, compilers, hex editors, utilities, all that stuff, but they were missing the kernel, the core.
So Linux filled the gap.
Precisely. Suddenly, you could combine the existing GNU software with Torvald Linux kernel, and boom, you had the first complete, functional, entirely free operating.
Which is why some people insist on calling it GNU,
right,
to acknowledge both parts.
Exactly. Stallman and the FSF make that point strongly to give credit to the massive amount of work the GNU project had already done before Linux.
Okay, so now we have a complete free operating system, GNU, gaining traction. Why did we need another? Where did open source come?
That's a really interesting point in the story. By the mid to late 90s, especially with the dot-com boom happening, free software was proving itself very, particularly on web.
Right.
The Apache web server, which was free software, app dominant. It was the A in the LMP stack, Linux, Apache, MySQL, Perl, incredibly popular, powerful, and free set of tools that ran vast. It showed free software could be commercially viable.
So it was working in practice.
Definitely. Then a couple of things happened around 97, 98. Eric S. Raymond published a very influential essay called Cathedral and the Bazaar, analyzing how the free software community built things so effectively.
Okay.
And then Netscape, a huge company at the time, made the massive decision in 1998 to release the source code for its Navigator web browser as software.
That must have sent ripples through the...
It really did, and it prompted a strategic rethink within parts of software. Some felt that the FSF strong focus on ethics, and maybe the ambiguity of the word.
You mean free as in price versus free as in freedom?
Exactly. They felt that language might be putting businesses off. They worried companies saw free software as commercial or just, well, confused.
So they wanted a different angle.
A group got together for a strategy session in Palo Alto, and Christine Peterson, who was there, suggested the term open source.
Open source.
Yeah. People like Eric Raymond and Linus Torvald were involved in adopting. The idea was to rebrand the concept, focusing less on the ethical imperative of freedom and more on the practical benefit of having the source code of better quality, fast development, business advantage.
So highlighting the development model itself.
Exactly. They formed the Open Source Initiative, or OSI, shortly after, specifically to promote this term and its business-friendly message.
A pragmatic rebranding, essentially. How did Richard Stallman react to open source replacing his term free software?
Well, he acknowledged the strategic thinking behind it. He apparently flirted with the term free, but ultimately he rejected it.
Why?
Because for him, it missed the entire point. It sidelined the core issue, which was user freedom. He famously said something like, free software is a political movement, open source is a development.
Well, that's a clear distinction.
It is. It created this split in terminology. Within the community, you hear FOSS now, free and open source software. But it's important to say Stallman still considers open source advocates allies against the common enemy, proprietary closed source software. They just have different motivation priorities.
It's clear this whole movement, whether you call it free software or open source, has massively changed the tech world. But let's bring it down to us, the everyday user. What are the real tangible benefits we get from open source?
Oh, the benefits you, and they touch every. First off, transparency. With open source, you can actually see the code. There are no hidden backdoors, no secret functions, theoretically.
You know what the software is doing.
Exactly, which lead directly to better security. There's that famous saying, given enough eyeballs, all bugs are shallow.
Meaning, if lots of people look at the code,
they're more likely to find and fix vulnerabilities quickly, often faster than a single company could with its closed code. It's security through transparency, not a...
That makes a lot. What about cost?
A lot of open source software is cost-effective, often complete free down. You think about operating systems, off-web web browser. The savings for individuals, schools, businesses, government are astronomical, billions,
and beyond cost.
Huge customers. If a piece of open source software doesn't quite do what you need, you or someone hire has the freedom to modify, tailor it. Proprietary software rarely give that.
Right, you're usually stuck with what vendor gives.
Exactly. And it's an incredible learning resource. If you want to learn programming or understand how complex work, you can just dive into source code of world-class software. It's like having the blueprint to the
It sounds like it also fosters a different kind of development process, much more collaborative.
It's fundamentally collaborative. It arguably created the largest, most distributed collaborative effort in history. It really breaks down barriers. Doesn't matter if you're a student in India or a top engineer at Google. If you have a good idea or a good code contribution, it can get included based on merit alone.
That must speed things up.
Hugely. It accelerates innovation. Developers aren't constantly reinventing the wheel. They can build on existing shared solutions, focusing on the next step forward. And the overall economic impact is just staggering. One study estimated it adds something like $8.8 $8 trillion annually to the global economy.
That's incredible. Just mind-blowing. Can you give us a few really concrete examples? Like, what are some of these open source giants that we might be using without even knowing it?
Oh, for sure. Let's start right at the foundation. Linux. We mentioned it. Linus Torvalds kernel. It powers Android phones. Most of the world's web servers, something like 90%, almost all the fastest computers, cloud platform ever.
Okay, so Linux is underneath so much. What about the tools developers use or things driving new tech like AI?
Right. Python, created by Guido van Rossum, become the dominant language for AI, data science, machine learning. Relatively easy to learn, incredibly powerful libraries.
The tools building the future are often open.
Very often. Look at TensorFlow. This is Google's framework for machine learning. They open sourced it in 2015, and that act really democratized AI development, letting researchers and companies everywhere build sophisticated AI. And Git, another one from Linus Torvalds. It's the system nearly all software developers use to manage versions of their code and collaborate. Platforms like GitHub are built on Git. It's the unsung hero of modern software development.
Okay.
And you've got others like the Apache HP server still powering websites, MySQL databases running behind the scenes, React for building user interface. The list goes on and on. Embedded.
It's fascinating how software is dominated by this. But you mentioned earlier, it's not just software anymore, right? The open source idea has spread.
Yeah, that's a really important point. The model, the philosophy has proven really adaptable. We now see open source hardware, things like Arduino microcontrollers.
I've heard of those. Little boards for electronics projects.
Exactly. Hobbyists, students, engineers use them. The designs are open. Or the Open Compute Project, which shares designs for efficient data center, hardware servers, rack, cooling system. Big companies collaborate on.
So even physical things can be open.
Absolutely. There's even, kind of amusingly, open source food and beverage. People have created recipes for things like open source colas or even free beer, mainly to illustrate the concept. The recipe is the source code.
Oh, okay, I get it.
And think about digital content. Wikipedia is maybe the ultimate example. It runs on open source software, and its content uses Creative Commons license, which are very much in the open source spirit, free to reuse and adapt. And it's pushing into medicine, scientific research, even construction with things like WikiHow, sharing open designs for building house and education. MIT's open core Hanukkah. The principles are spreading far.
Okay, the benefits are clear, the reach is massive, but it can't be perfect. What are some of the challenges or maybe downsides to relying on open source, especially if you're, say, a big company?
That's fair. It's not without a complex. One thing can be support. With proprietary software, you usually pay for a dedicated support. With open source, support often comes from the community forums, mailing lists, documentation.
So you might have to dig for answers.
You might need to hire experts or pay a third-party company that offers commercial support for projects. So support complexity is a factor.
Okay.
Compatibility can sometimes, with so many different project versions and dependencies, getting everything to work together smoothly can sometimes require more effort.
Integration challenge.
Yeah. And quality variation. While top-tier projects like Linux are incredibly robust, some smaller or newer projects might be less polished, more experimental, or have fewer maintainers. You need to evaluate project carefully.
Makes sense. What about security? You said it can be better, but are there risks?
Well, the transparency helps find bugs, but it also means potential attackers dead the code too. The main thing is security responsibility. With open source, the responsibility often falls more on the user or the organization to apply patches, figure things correct, and stay vigilant. You can't just assume the vendor.
So more power, but also more responsibility.
That's a good way to put it.
It sounds like even the giants of the tech world, companies that were built on proprietary software, have had to grapple with it. You mentioned Microsoft earlier.
Oh yeah. Their journey is fascinating. From calling the GPL a cancer in the early 2000s
Right.
to becoming a top contributor to open source projects on GitHub and a platinum member of the Linux Foundation by the late 2010s, that's a massive reversal.
Why the change? Just pragmatism?
Largely, yeah. They realized they couldn't fight it. And more importantly, that embracing open source was strategically smart. It helps them integrate with the tools developers actually use, participate in innovation, and leverage cloud platforms which heavily rely on it. It's a business decision, even if it doesn't fully embrace all law.
And platforms like GitHub, you meant Git earlier, they must have played a big role in making collaboration easier.
Absolutely critical. Before GitHub really took off around 2008, contributing to open source could be quite technically involved. You had man patches, maybe email them to maintainers. It was clunkier.
Right.
GitHub, built on top of Git, made it incredibly simple. You can fork a project, make your own copy, click, make change, then issue a pull request, asking the original project owner to pull your changes their code.
So it streamlined the whole process.
It lowered the barrier to entry for contributing and made global collaboration seamless. It's been a huge catalyst for the close growth, ongoing success move. It really democratized it.
So wrapping this up, we've journeyed from the early days of code sharing through Richard Stallman's fight for software freedom with the Mio project and the GPL,
to the emergence of Linux, the strategic shift with the term open source, and now this global movement that's impacting everything from AI, cloud computing, to hardware, and even bureaucracy.
It really is a powerful testament to collaboration, showing how working together openly can often achieve more, faster than keeping things locked down.
It truly is. It proves that collective intelligence, when harnessed, that can drive innovation and benefit society in ways that purely competitive, proprietary models often. It's redefined value.
So, as we finish this deep dive, here's something to think about. If this open, collaborative model has achieved so much in technology, where else could we apply it? What other complex problems, maybe even in your own daily life or community, could be tackled differently if the source code, the underlying information, methods, or designs was open for everyone to see, use, improve, and share?
It's a powerful question. We really hope this discussion has given you a new lens through which to see the digital world around you and maybe beyond. Thanks so much for joining us.